Hello and welcome to our second data analytics portfolio project here on the channel. If you're a data analyst or want to get into the field of data analytics, it's often pretty good to have a portfolio of different projects. Now, last month I did a project that was SQL heavy. We pulled some data online from baseball stats of Rays pitchers, threw it into the Excel, made a few updates on the sheet, and then put it into a database through a few different tables and ran a bunch of different queries on that side of things. Well, I wanted to go to the opposite spectrum today, and we're going to be doing a Python project based off of exploratory data analysis. Now, where we're going to be grabbing this data from is Kaggle, and it deals with actually one of my favorite hobbies out there, which is ultra marathons, which sounds crazy, and it is. So for some background information, an ultra marathon is anything that is farther than a marathon. Now, the smallest distance is a 50K, but it can go all the way up to 200 miles. Now, the first I ran was a 100K, and I did that around UCF's campus kind of as like a funny graduation because my graduation got canceled. I ran a 50 miler before in the Everglades and a few other 50K races, including one earlier this year. But I have a 50 miler coming up within a week, and I thought it'd be really fun to build out a project based around some data on it. So I was able to source a data set with years of ultra marathon races. So I wanted to run some EDA analysis in there. And then also I wanted to see if I was actually in the data set. So let's go through this whole process. And before we jump into this portfolio project, if you guys could please subscribe to the channel, since it does take quite a while to build out these projects, and subscribing is 100% for free. It helps grow the YouTube channel and allows other people to access the videos that we make here. There's also tons of resources here on the channel. I make Python and SQL videos weekly, so that way you guys can grasp the concepts and then implement them into these projects. All right, let's go up on my computer and let's first grab this data set. Okay, so I have a Jupyter Notebook loaded over here. First, I have this link to the data set. I will put it down below in the description so that way you guys can access it. But just to show you what you need to do on the data set itself, so I loaded this up already in Google Chrome. So the big data set of ultra marathon running collection over 7 million race records registered between 1798 and 2022. Definitely interesting, the 1798 side of things. That's pretty cool. But regardless, to show you guys how you can do this, just go over here and click download. And then you're going to have this zip file. So once this loads, I'll show you what to do next. So now that I have this over here, all you have to do is right click it and extract here. And then we have this file. It says 2 centuries of races. So what I'm going to do is rename this file. This is a CSV, but when you import this in, it's probably easier just to label that. So now you can see on, at least on my computer, it turns this into something that can be opened up in Microsoft Excel. So we're going to go back over here to our Jupyter Notebook. I'm just going to open in a new tab, just go to over home, and then just click upload, and then make sure to upload that specific file. Now, I've already uploaded that file in here, so you can go over here to last modified, right? And you can see this over here. So 2 days ago when I first started this project, 2 centuries of ultra marathon races.csv. So make sure that is in here, just again, upload it, and then you are ready to go. And with that imported, let's start this video. So I'm just going to build out a bunch of cells, and all I'm doing is pressing this plus icon because we're going to be coding quite a lot in this video and marking up what we're working on specifically. So the first thing that we always want to do when you're going to be working in a Jupyter Notebook is import the libraries that you need. So just put import libraries like this. Now I'm going to be using only 2 in this video. So the first one we're going to be importing is pandas. So import pandas as PD, shift enter. And the other one that I use in this video is going to be import Seaborn as SNS. And I have a full video on Seaborn as well. It allows me to show different graphs and charts pretty easily on here. But if you don't have Seaborn installed yet on your machine, just pip install Seaborn. Very, very simple. Okay, so now we want to create our data frame based off of the data on the ultra marathons. So to do that, we're going to put df, which is going to be our data frame, equals pd.read_csv. And then we're going to put in that file name, which is 2 centuries of races. And I've already done this, but I'm just going to copy and paste this over here so I don't make any mistakes typing this. And then our data frame, once this loads up over here, should be this CSV. And I'm just going to make a note on here. See the data that's been given. It's been imported, right? And we already get an error over here. D-type warning, columns 11 have mixed types, specify D-type. So there's already going to be a lot of issues with this data set. And I already know there is. It's what, 7 million records? So nothing is going to be perfect with that size. But just to show you what this specifically looks like, we can start off with a head. So df.head 10, and that'll show us the first 10 rows associated with it. We can shift and enter. And this is the breakdown, right? So you have year of event, and these are all going to be 2018 over here. We have event dates. Now, this is European style. So if you're not familiar with European style, the months and days are switched. So technically, this is the 6th day of the month, this is the month, and then this is the year, which gets interesting when you're going to perform some analysis. And we're going to do this a little bit later in the video, kind of how we transform this event date to find some pretty cool data on seasons for ultramarathons. Because if you don't know, running in summer is a lot tougher than running in the winter. And I say that with them both around 50 miles in 95-degree weather. Okay, we have event distance and length. So we have 50 km over here. But the thing that's interesting about ultras is you have a lot of different types of races. You have like 24-hour races, you have 12-hour races, you have 50-mile events. So this is going to be all over the place. It's going to be tough to do some calculations with this. So we're going to have to edit this down quite a bit. Number of finishers for the race, athlete performance. So you can see like we have an H at the end. I don't like that specifically, but that's been in there. Athlete club, athlete country, athlete year of birth, athlete gender, category, average speed, and ID. Also, this is interesting. Age category, we have M and probably F as well on here. And it's all over the place. This will need to be cleaned up if we're going to perform any analysis as well. This is kind of nice, right? The average speed, which I assume is going to be in like kilometers. Because if you look at this over here, 10.286, right? 4 hours and 51 for a 50K. So I assume like pretty much more than 10 kilometers per hour across the board. So not super descriptive on that side of things. And then athlete ID, I assume this is a unique identifier for each athlete that's going to be within this data set. So there's probably hundreds of thousands of different athlete IDs associated with it, but this is kind of how it's built out at a higher level. Now we can also just do a shape. So df.shape, and this will tell us, you know, we have 7 million records, and then we have 13 columns associated with it. And then we can take a look at the D types. So we got an error earlier, right? That there's D types that are just weird in this. So we can do D types, and then you can see how everything's associated with it. So like your events, int, event dates, object, object, int, object, 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 float, object, 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 and then we have an int over here. So I think the first thing that we should do, since this is 7 million records, is cleaning up the data. So we're going to say we're going to clean up data over here. And what I want to do first is I just want to show USA events, 50K and 50 miles within 2020. So I had a 50K race and a 50 miler in 2020 that were official races beyond my 100K. So I want to see my own data within this resource. And I think the first way we should do that is just kind of, you know, go from 7 million records to whatever it ends up being. So we'll just put over here, only want USA races, 50K or 50 miles, then 2020. So I think the first thing that we should do is make sure what 50K and 50 miles shows up as, and that's under this event distance length. So step one, show 50 mile or 50K. So it's kind of interesting on here. So we already know what 50K is, right? It's gonna be this. So I'll just put over here, it's gonna be 50 kilometers, but we don't know what 50 miles is. So I'm just gonna grab this and we're gonna start testing, right? So what I'm gonna do is a df.query. And what I wanna see, well, actually we're not gonna do a query yet. we'll do that a little bit later once we fix up some of these, because there's spaces in here and it's kind of annoying. So we're just gonna go like this, DataFrame, put brackets in here, and we're gonna go inside and DataFrame, and then we're gonna grab that column, which actually we already have it over here, event distance length. And the first thing that we're gonna try on here is equals, and then we're gonna put over here 50 km, just to make sure that this works properly. And you can see 50 kilometers is working. So that's good, right? We have a bunch of different stuff over here. Next thing I'm gonna check is just if something's been inputted as 50K, because that's a very familiar what it's like most of the time at races. But you can see there's nothing for 50K. So it's always gonna be 50 km within this data set. Next thing is gonna be miles. So usually it's gonna be labeled as 50M, but it could also be 50mi. So let's try 50M. There is nothing in there. So my assumption is gonna be 50mi. And then you can see 50mi is showing. So we'll put that as a note, right? We need to put over here 50mi, so that way it is filtered out like that. So what I'm gonna do is now combine both of these, and I'm gonna do that with is_in. So combine 50K and 50 miles with is_in. And this is just to show that I know quite a few different things with Python. I could just do an OR statement in here, but is_in is way more efficient. So again, portfolio project, show off your different skills. So what we're gonna do is go back over here. I'm gonna honestly just copy a lot of this because I don't want to type it out again. Put that over here, right? df event distance is that. And then what we're gonna do instead is put .is_in. And then we'll have this in here, we'll have that in there, and then copy that. And then we're also gonna put 50 km, comma, and this should work, right? Let's move all of that. So bracket, bracket, bracket there. I think we should be good with brackets, right? And that alone has dropped us down to under 2 million records. So it's a start, but we're not in the best area yet. And let's now move on and start adding in 2020 only. So what we're gonna do is continue with this. Now, I'm gonna put an and in here, and that way we can start looking at 2020. But one thing I should mention is when you work in data frames like this and you start with ands, you need to wrap these in parentheses like this. So wrap those together, right? And then we have and this time we're just gonna do df. I'm gonna copy that and say equals 2020. Now we have to change specifically what that is because we're gonna grab year of event, which I'm just gonna grab this like that to make sure we don't have any issues, and put that in here. And like on this side, that wrap that in the inside over here. It's an annoying bit of pandas, and this is very ugly, I agree. But now this will just show 2020 events. So boom, right? We can see over here year event 2020, and look at that. We're now down to 63,489, which is a lot nicer to work with than that initial 7 mil. And we still have to combine it with USA events, right? So we need to look at specific USA ones. And one thing I noticed on here is we have the countries that are associated with event names. So you can see like TPE, TPE, TPE. Then we have POL, which I assume is Poland. I actually don't know what TPE is, so I'm going to look that up, right? Taiwan. Actually, I should have known that one. But regardless, each of these races has something here at the end. So just to confirm this theory, I'm going to look up a race that I ran, and that is the Everglades Ultra, and that's based out of Florida. So I'm hoping that it doesn't have FL in here, that this would just have USA. So let's take a look at that. So DF, right? DF, and then inside over here, we're going to have to put event name like that. So hopefully no issues. We have event name, and we're going to say that's equal to, and then Everglades 50-mile ultra run USA like this. Okay. And see if it shows up like that. And the race is here, right? And obviously we have other years because I didn't assign this back to DataFrame yet, to 2020. But this is working. We see USA here at the end. Good. Okay. So now we need to figure out how we can pull this USA section and then filter by it, because essentially we just want those results. So what I'm going to do is something like this. I'm going to put our event name once again. I'm just going to put a .str.split, and I'm going to put in here. And what I'm hoping this does is split this up. So we have Everglades here, and then we have USA. But the thing that's nice is all the USAs are going to show like that. Then if we just add in one extra line and do .str.get1, it'll just show USA. And we can add that into what we have over here essentially and start filtering out things. So, but I'm going to go one step farther. I'm going to do this all over again and watch this. So I'm not going to put that get yet, but I'm also going to split at the very end. So now we just have USA here. And then since it's in this first spot over here, I'm just going to put this. And the first spot is going to be a 0. That's just how Python works. And you can see now we just have USA. Again, super, super ugly, but it works, right? Which is good. Now, we don't need this Everglades anymore, but I'll show you what we can do. So we have this on here. I'm going to remove a lot of this. But we can have all of that in here. We can put this equal to USA. And essentially, if I coded this correctly, this will show all the different events that took place in the United States. And about 30 seconds later, we have all these events. And again, tons and tons of records. But you can see like Yankee Springs is now over here, West Virginia Trilogy. And it's good, right? USA. So now let's add in this additional filter. So we'll say combine all the filters together. Okay. So let's go back over here and copy this ugly code and add in one more over here. So this time we're just going to copy the inside of here. We're going to put this like that, and we have all of this. So we have event length distance 50K or 50 miles. We have year event is 2020. And then we have the string split to get USA. So this will give us our results for USA events 2020 that are 50K or 50 miles. Shift and enter, assuming that nothing was wrong coding. It'll take a second. And there we go. So our total now is 26,000 rows. And again, way, way nicer. So I want to just relabel this now. I'm just going to copy this over here. And I'm going to say that this is going to be DataFrame 2. And is it ideal to name it DF2? No, absolutely not. But in this case, I'm just going to say DF2 equals that. And then if we just do a DF2 dot head, we'll say like 10 in here. This has to run still before this can. But you'll see once this loads, then you can see this is working correctly. So perfect. And just to run the shape on here, df2.shape 26 and 13. So now let's continue to work on this and clean up data. So next thing I want to do is remove this USA from the event name. In my opinion, it's kind of ugly since all of these records are going to be in here anyways. So I'm just going to say remove USA from event name. Like that. Okay, so all we have to do on this one, so we'll put df2, put event name, and we're going to rename all these columns too so we can start running some queries on it. Don't like spaces on columns. It's really annoying. But regardless, and we'll do str.split, and then threw that in there. We got to throw this also, which I guess I could just put that here. Dot get, well, it's dot str, then get str, dot get, and then I think we're going to throw 0 in there. And that just has this side of things. So again, we want to have this correct. Just say it's equal to it, and that'll overwrite it. So probably get an issue on here, but this does overwrite it. And if you just want to see df2.head, USA is now gone. So great. So the next thing we're going to do is clean up the athlete age. So I'm just going to clean up athlete age. So we already have a column for male and female, but we have like M23 or MU23, M35, M40. Pretty ugly. So what I'm going to do, and this isn't 100% the correct assumption, but I'm going to take 2020 minus the athlete birth year to get the age on here. And again, there's going to be exceptions on this, but that's what I'm going to do on this example because this is a category. And essentially what happens in some races is you'll have like a men, let's say, for example, under 35 category, and you're going to be automatically assigned that. Like this one, M under 23. So this person was born in 1999. This race took place in 2020. And since I don't have the exact birthday of the individual runner, the athlete ID, I'm sure there's another table associated with it somewhere out there. It's just very tough to do. But all these races are 2020. So I'm going to take 2020 minus this athlete year of birth. And that's going to be the new athlete, like kind of like age category on here. So what I'm going to do is have this. We'll say df2, and let's start with the correct proper naming. And we're going to say athlete's age, and that's going to be equal to 2020 minus df2, and we're just going to copy this, but it's now going to be at the year of birth. And because I want this to show up as an int, I'm going to say as type int on here, and I believe this should work. And it does not work. Cannot convert non-finite values, NA or INF, to integer. So that did not work. Assume then we're just going to have to think if you just put this on here for now, that'll work. And it did work, which is nice. Okay. And then the next thing I want to do is remove this H from athlete performance. So say remove athlete performance. And the way that you do it is kind of like as above where we did this string split. So I'm just going to copy this over here. And then I'm going to grab is athlete performance. I think this should be it. I'm just going to put that here for now. Well, the reason why that's not working is we have that. But that does work here. So just throw that over and boom, that has been put in there. And then just put df2. Then just put df2 dot head. And just to show you both of those are working now. The hour is gone from athlete performance. And we have athlete age on this side of things. So now we can start dropping some columns. So drop columns. So what I want to drop first, I don't care about this athlete club. So we'll say athlete club. Athlete country, I don't care about as well. Athlete country. Athlete year of birth, because we already have essentially what we need on that. Athlete year of birth. An athlete age category. All those can go. So let's drop those specific columns. So all you have to do is df2 equals df2.drop. And then let's put all of those in here. And this is going to be a little tedious, So sorry, but that is how it sometimes goes. So just grab all of that. So athlete club, athlete country. And again, could just type all these out, but then you make a mistake. So I'd rather just grab this. Then we have to label axis equals 1. So it lets it know it's the columns that we're dropping. And then I think that worked. So df2.head. And again, way nicer already. You can see how this has been changed. So now we should probably clean up any null values that we have. I know we got an error earlier. So let's clean up null values. So the first thing that you should do, and I'm going to just add in a lot more cells, so there's so much more work to do on here. So we can do so df2 dot is an a, and then dot sum like this, and this will essentially tell us where these nulls are. And we have 233 with athlete age, which is why earlier we couldn't do that as type for an int. So just to see essentially how these are showing up, we can just do df2, throw in here again df2, single quotes. I'm going to put athlete age in here. We're going to put dot is an a. We're going to say that's equal to 1. And that'll just give us examples. So it looks like a few different events just, did not have an athlete age. North Carolina, fat, Big Bend, quite a few for Big Bend over here. Man against horse. So that's a shame. But we can just drop these pretty easy. df2 equals df2.drop na like that. That will drop those 233 rows. Now, if we just do over here df2.shape 25857, which is 233 less than what we had earlier. Now, we should also check for duplicate values. Check for dupes, and pretty easy too, right? So all we have to do on this one is df2, and then we'll just put over here df2.duplicated. This is true. Shift and enter. And I do have an error. So what is my error? DataFrame object has no thing for duplicates. Meant to put duplicated. And you can see that there's nothing in here that's been duplicated, which is good. So now let's reset our index. So I'm just going to say reset index. And pretty easy. You see me do it quite a lot on the channel. df2.reset index. And then we'll put drop equals true. So that way we don't get those weird index columns. And then now we have 0 all the way through 25856. We're looking pretty good, right? Next, we're just going to fix a few types. Now, there's a lot of issues in here. I'm not going to lie, and this video could be way longer if we really analyzed everything in particular with this data set. Just being truthful to you guys, take quite a while to do everything. But we can fix a few of these. So the first thing I would like to fix is that athlete age from earlier. So easy way to do that is df2, put over here, athlete age, it's going to be equal to, and then we'll just copy that again, dot as type, let's just throw int in here. And that worked. Awesome. And then I want to do the athlete average speed. I want to make that into a float. So I'm just going to copy that over here, that there. And these are just some of the calculations I'm going to do a little bit later in the video. So just make sure that you prep that. Float on here. And that worked too. And then if we just put df2.dtypes, right? Let's see, int and also float. Again, feel free to clean up any of these as you go. But I won't be using some of these other columns or series a bit later in this video. And just to show you guys also this didn't impact, we can just do df2.head, and we have this all over here, which is good. So now we want to do, and And just to show you how this has worked, out the age rate 29, 39, 21 in comparison to the past, you had 0.0, just cleaner in my own personal opinion. So now something I've wanted to do for quite a while because couldn't really use query in here is I want to rename columns. And just to grab the column names, you can just copy these and put them down below over here. And I'm just going to do that real quick. Throw that here and just comment these out. Now, why I'm renaming the columns, I don't like these spaces in here. And I just want everything lowercase, just so much easier to code out. And you don't make mistakes on that side of things. I mean, you will, but like a lot less mistakes with accidental capitalization, either like the first part or the last part. And also, I don't like the names of all these because it's like event. I like put race. At least that's what I want to do. But df2, and we're going to say this is equal to df2.rename. And then just put over here columns equal, and then you're going to be building out this this bundle of joy. So what I recommend just to do really quick on here is just start copying these. This, we're going to put a colon, and then we'll say whatever it is at the end, right? And then comma. So just go through here first and just copy all these, or you can just copy my code. I'm sure I'm going to put a link to it on GitHub. So if you want to save yourself a few minutes, you can skip ahead and copy the code. Just to show you how this works though, let me do these first three over here. So for example, like your event, I'm just going to literally just put year. And essentially what this code will do is it'll go over here from year of events and it'll change that column to year. Next, we have event dates. I'm just going to name this as race day. So race, then underscore day. So that way we can throw that in a query function. And then event name, I'm literally just going to put race and underscore name and race name like that, and comma. And I'm going to rename all these. So I'm just going to copy over what I've already done. And you guys can see how that is. Again, feel free to pause the video and type all of this out, or just copy my code, shift and enter. And all these columns have now been renamed. Which is really nice. Again, you can just go df2.head and boom, we have all this over here. Cool. The next thing I'm going to do though is rearrange these because A, it looks good for this project, but also B, I don't like this order. So reorder columns, and I'm just going to enable this as df3. So df3 equals df2. And essentially what you're going to do is put the desired order in here. So let's say, for example, I wanted to have race day as the first thing on here. You could just put race day like that. And then boom, that'll be the first thing that shows up. And again, like the one up here, I'm not going to waste your time and just put it all here. I'll have the code down below in GitHub. So I'm just going to copy what I've already done. So now this is in here. I'll shift enter and just do a df3.head. You can see how this is built out. Now, the one thing I did end up deciding is not to put this year column. All the races already in 2020. We also have this race day in here, although it is not formatted properly. And we'll go over that a little bit later because there's a reason why I kept it like this. But regardless, we can see everything here versus we had to technically scroll over a little bit on here. Not a big deal. But again, just a conscious choice just to remove that year. Keep it if you want, but I decided to remove it. So now here's going to be a really fun part. I'm going to locate the two races that I did in 2020. And also do want to caveat, there's a lot of other ways that you could clean this up still. And this is nowhere near like a final version of what this should be if you're going to really dive deep into the data. So just as you know with that, and again, there was over 7 million records. So there's quite a few different directions that you could do. You could do different comparisons on types of races like 50K, 50 mile, 100 mile, 200 mile, right? The average speed. You can compare races in the US compared to other countries. Like, again, so much you could do, but one video, right? So I just want to show you guys what I want to do for a fun project. So now that we have the basics of the data cleaned up, let's now look into the two races that I ran in 2020. So Sarasota and also the Everglades. So all we have to do first is df3, and inside df3, we're just going to put over here race name. Grab that. And this needs to be equal to the Everglades one that I had earlier. Where is that at? Everglades 50 mile there. And I'm just going to put that in here. Shift enter. Nothing's showing up. So let's see if we have a space here at the end. And we do. So here's that. Now to find exactly where I'm at in here, we have a gun time of 9:19. So if we go down over here, right, that is me, this athlete ID. Now, just as a caveat, there's two Ryan Nolans that run ultras about the same age. I'm 22 here. There's another one that's 23, as weird as it sounds, but he's from Missouri. I am from Florida. Now, my results in 2020 show up here, but I think it's like in 2018, he had some ultra marathons. And for some reason, I don't know if it's runner sign up or just another running website, they put both of us under the same athlete ID. So that should get fixed eventually in the future. I have to reach out to them still, but regardless, if we want to see my other race that I did, not the Everglades, but the Sarasota one, we have 222509. And then all I'm going to do, I can just copy this over here and we will grab athlete ID. We'll say athlete ID equals here. And yeah, Sarasota ran that under 5 hours and Everglades under 10 hours, but you can see how big of a speed difference. Now Everglades, closer to summer, tougher race and longer distance in comparison to the Sarasota one, which was a warm up for me, but lots and lots of sand, although I did enjoy that race. So those were the two, finding them. And again, athlete age is wrong in this example. It should be 22, but not the end of the world. Okay. Now let's take a look at some charts and graphs for this data. So this is where we're going to be using Seaborn that was a little bit earlier. So the first thing I want to see is a histogram plot based off of the different race lengths between the 50K and 50 miler. So it's my assumption that there's going to be less 50 milers because it's a lot more challenging. So we can just put sns.hist plot. And we'll just put in here df3 race length, like that. And you can see there's quite a lot more 50Ks than there are 50 milers. Now we can also overlay males versus females on this side of things. So if we just copy this over here, and we're just going to do a few different things. So first, we're going to say our data equals df3. Data is the first thing on here for the hist plot, and most of the things for Seaborn too. And then we can just put x equals race length, like that. And then you put a hue, which is the overlay, and that's categorical. So versus numerical. And then you can put athlete gender in here. And you can see for like 50Ks, there's a lot more even on here between males and females in comparison to this 50 miler. Which is predominantly male. So now I want to take a look at a dist plot just to see the distribution of 50 milers, especially when it comes with the average speed. So we're in sns.dist plot, and normally you could just throw in specifically what you're going to see the distribution is, but we're kind of going very specific with the average speed for 50 milers. So the way that you can do that is df3. And grab the inside of this. So df3, we're going to say race length. And we're going to say that's equal to 50 miles. And then on the outside over here, we're going to put athlete average speed like this. And you can see the distribution. So it's pretty common to be around a 6 or a 7 speed. And just to show you guys, when I ran this in shape, I was at 8.6. So if we see that, better than average. But thing is, this is just general for courses, and every 50 miler is different. You're gonna have some very, very technical ones, like they go up steep mountains, but you're also gonna have road ones. So unless there is like something in here that showed the difficulty. It's tough to kind of view the speed of 50 milers on just like an equal level. Again, for this data set, it's kind of cool to see this, but just as a caveat for ultra running, not all 50 milers are the same. There's quite a lot of differences on those. The next thing I want to show you guys is a Violin plot. I think these are actually pretty fun to do. So sns.violin plots. We're going to say df3, or you can also just put, just as a heads up, you can say data equals df3. Either or, I'll just put that for this example just to change up the code a little bit. And then we're going to put over here race length again, length. And then on the Y side, we'll put athlete average speed. And then hue, we'll say that's equal to the athlete gender on here. And this is just a basic one on this side of things. You can actually add in a lot more additional information just to kind of spruce this up a bit. So you can say split equals true on here. Then you can say inner equals quartz, like that. Then line width is 1. And check this out. I think it looks a little bit nicer in here. And you can see male versus females. Males are a little bit faster on the 50K. And they're actually a lot closer on the 50-mile side of things. One thing that's kind of interesting for ultra marathons is for some of the races, like 100 milers or 200 milers, you do have females winning in comparison to the males. So like in a lot shorter distance, males tend to win in running races across the board. But when you get in that farther distance, there's a lot more elements to it. A lot of strategy involved with ultra marathons and mindset, and it gets a lot closer. I bet if we went to 100 miles or 200 miles, these would be even closer together, which is quite a shock to some people. But you got to remember, when you're getting to that distance, this is the best of the best runners, and you have to dedicate so much time to even be able to complete one of these type of races. Another one that's kind of fun to do is a LM plot. So SNS.LM plot. And then what we can just put in here is data equals df3, x equals, and we're going to do a lot of the same things, right? So we can put athlete age, I guess, athlete age, which this needs to be in single quotes. I don't know why I didn't put that in there. And then y equals athlete average speed. And then we can do, we'll show this first and I'll show you also what a hue looks like after. So this is very tough to see specifically what's working. But this pretty much shows you all the placements between athlete age and then the speed. So it makes sense as someone gets older, they're going to run a bit slower. So you can see over here, some very fast, some very slow. And the crazy thing is there are ultra runners in their 70s or 80s. Imagine running that much at that age. Crazy, right? But we can also put over here, hue equals athlete gender, kind of like we used earlier. And even break this down even more. So let this load. And then you can see male versus female. So there is a bit of a gap on here between the 50K and 50 miler combined, especially with this data showing that there's significantly more 50K data within here, but pretty cool type of a graph. So now these are just like questions I want to find out from the data set. So questions I want to find out from the data. And just to make things easier too, I'm just going to copy over this, which is some of the different things that we'll be using specifically. So here's the first one, right? So I want to find the difference in speed for the 50K and 50 miler male to female. So we're going to be using a group by statement. And I just want to show a few different ways, again, showing that you know how to use Python. And again, this stuff's been pretty intricate. We're already 71 lines through it. And like, we've done a ton of work so far. And also just a quick caveat before we move on to these questions. If you're still watching, make sure to subscribe to the YouTube channel. Again, this takes quite a lot of time to plan out these type of videos, build out the code, and then I have to rewrite it for the videos as well. and then even edit the videos. So if you can spend 10 seconds subscribing to the channel, it does really help. These take hours upon hours. And if you do want to also practice some Python questions like these over here, but for more interview based, I have a link to StrataScratch down below in the description. Now it's 100% for free. If you do get a paid plan, it does help with the channel through an affiliate sale. I do want to hire an editor in the future so I can push out more videos, and that fund will go towards hiring an editor. All right, let's continue going forward. So what I want to do for 50K, 50 mile male to female is we're going to do a group by. So we're going to do df3 group by. Then on the inside over here, first thing we're going to do is race length. So race length, and then we're also going to put athlete gender on here. And then on the outside of things, we're going to put athlete average speed, and then we're going to put dot mean. And then you can see over here, male versus female. So again, female, we have 7.08, male, we have 7.7. So like about 0.7 of a difference, but 50 miles, female 6.83, male 7.2, so 0.4. So again, very close on here. And this is just the mean, which isn't the best example to use, but just to show you it's closer on that side of things. So next thing I want to see is what age groups are the best in the 50-mile race. And I want to see also 20 plus races minimum. So ultra marathons is predominantly people like later 20s, 30s, 40s, things like that, especially more time. And really you can develop that skill set versus younger age tend to be shorter distances. So having some teenagers in here or early 20s might skew the data a little bit. So that's why I'm adding in this 20 plus race minimum. Also, it allows me to build out a little bit more of a complicated code over here too. So the first thing I want to do is query this. So we're going to put query, and then we can just do race length, and we're going to say that's equal to 50 miles. So now we can do our group by. So you can just say group by, and in here you can do athlete age. And then next thing we're going to do is athlete average speed. Then we're going to put a dot ag, and then in here we're going to do mean and also count like that. And then we're going to sort our values. So sort values, and we're going to sort by our mean, and we're going to do ascending equals false. And if you thought we're done, we're not. There's more. So you can just do a query, and inside over here, we're going to say count is greater than 19. And then we'll just put like head, and we can just do something like 10 or 15. We'll just do 15. And here we go. So the fastest age is 29, which makes sense. This is kind of like your prime for ultra running, I'd argue. So 29, 7.9, 23 is next at 7.77, which is really good. So just to see where I was at, curious. Obviously, again, I was at 22 when I ran this race, but I was at 8.6. So again, still above average for my age. Happy for back then. Although this next 50 miler, way tougher, 95-degree weather. I'm not gonna do well. Just tell you that. 20 pounds heavier too. A little bit of a chub down there, but anyways, 28, 7.5, 30, 7.5, 25, 7.5, and it goes down to 34, 7.3. And if we do it ascending equals true, just to see who the slowest, right? This does make sense. So 60, 62, 61, 63, 58, 64, right? Older ages, it makes sense on here. And again, we could just say age of the best. There, false. We'll say, what do we have, 15 on here? Show 15. And I'm going to copy this, paste this over here. And I'm going to say, what age groups are the worst in the 50-mile race? And just copy this code here. And then we can just put ascending equals true and changes 15 over here to 20. You can see that. And if we wanted the count to change to, let's say 10 plus, so we just change that over here. That way we can see some of the 70-year-olds and stuff like that. So 70, they're running a 50 miler, incredible. And 65, 68, 67, 66. So pretty cool on that side of things. If that inspires you to go exercise, I don't know what else will. Okay, lastly, and this is going to be using a Lambda function, one of my favorites. I'm going to copy over what I want to go. And seasons for the data. So are runners slower in the summer than winter? Should be, right? That's way tougher to run 95. So what we're going to do is go back over here. And there's a reason why I kept this junk over here, this race day. And we're going to be using that. And we're going to specifically look at spring, which I wrote specifically as sprint, which is nice, right? Summer, fall, and winter. Also nice. And it's not letting me copy that or edit that. So I'm just going to remove that over here. We're going to put spring and also winter. And then my hint on here was split between the two decimals. If you guys want to try doing that problem, you're welcome to do so. It is kind of difficult. And if you haven't watched my Lambda video, yeah, this might be tough. But if you haven't watched my Lambda video, watch it after this. So what I would recommend on this one, we start with df3, put over here race month like this, and then we're going to say that's equal to df3. We're going to say race day .str.split. Done this quite a lot in this video. Period in here. .str.get. And now we're going to want that middle section because it's European time. So we'll put 1 or European dates. And then as type int. So essentially what I'm doing is looking at this race day here, and I'm going to grab this middle section. And again, just as a caveat, there's probably some bad dates in here. Again, 7 million records. So this won't work for everything. But again, just a shorter video. We're going to assume that the dates are all going to be like this. So go down over here, and that works. So just to do df3.head. Right, go all the way over here. 2 is being grabbed on there too, which I guess you could say, why is it grabbing this? These are both 2/2020. Just do like a head of 25 or something like that. And you can see 1, 2, but this still grabs 2. So promise you it is working right now. I'm just going to remove this head because it is annoying. So now let's have something called race season. And it's going to be based off of what I had above. And we're going to say that's equal to, and we're going to grab this race month. So put that over here, race month like that. And we're going to do dot apply. And our world favorite, Lambda X. And then we're going to say winter. That if, and we have all these over here. So first, let's take a look at 12. So if x is greater than 11, else, then we're going to say fall. If x is greater than 8, let's space it out. Else, over here, summer. If x is greater than 5, else, spring. If x is greater than 2, else winter, like that, and it's closed out over here. And I think that should work. No errors, which is good. And then we'll put over here df3.head 25. And scroll over here. These are all winter. Cool. So I know this logic works because I tested it earlier, but essentially how this Lambda works in general, grab it winter if x is greater than 11, 8 fall, summer 5, spring 2, and then everything else is going to be winter, which will be 1 and 2. And if you want to get familiar with Lambda functions, again, full video here on the channel. And now we can do a full group by on this side of things. So we can do df3.group by, and then in here we can just put race season, right? And then over here we can just put athlete average speed like that, dot agg. Then you can put over here mean count. And then we'll just do a sort values. Doesn't really matter in this instance because there's only 4, but that's okay. And we'll just put over here mean ascending equals false. And then we run this code over here. So you can see it is the easiest to run a race in spring, but summer 6.8. So compared to spring, you almost run 1 kilometer slower per hour. And obviously the count is way different across the board, with summer being the least amount, but also makes sense why summer is the least amount, because that's the hottest and also toughest season. So there's a lot less races there. And just to show you like 50 miler only, it would be my assumption that summer is tougher because you're in more miles in the heat. And fun times for my race next week, but we can just go over here and put query this time. And then we're going to put on this side, single quotes, race length equals, and then in double quotes, 50 mi, and put a period here so that it can work. And now you can see the big difference as 7.5 versus 6.5, full 1 point in comparison over here, which wasn't. So yeah, way tougher with 50. So I'm sure with this side of things, like if we went to 100 or 200 miles, summer is going to be even bigger of a difference between that and fall, especially as the distance grows. But sometimes that makes ultras difficult too, is the world's toughest summer race, Badwater 135, is 135 miles. So it won't show up for a 100 miler. It wouldn't show up for a 200. And that's why some of these calculations can be tough. Hey, you're still here? Well, I appreciate you continuing to watch this coding video. I want to make a lot more data projects like this in the future. And the best way to support the channel, what's 100% for free, is by subscribing to it. Now, if you want to learn even more about Python, I have a full playlist over here. I go over some of the different concepts that I taught in this video, more in depth with other examples too. And some of them can be a little bit more difficult than what I showed over here. So make sure to watch those videos.